If you've ever tried to work with JSON using a standard Unixy tool like Grep or awk, you would know that it's really annoying to specify exactly what you want to grab because of the way that a JSON document can be structured. So it can be minified, and minified is basically where all of the JSON is put onto one line, and this is how you usually distribute it if you're sending it somewhere online. You have the regular form that you would normally write where basically every bit of information is on one separate line, but JSON also doesn't care about extra spaces, so you could just put a bunch of blank space in there for no reason, and it just becomes harder to grep, but it's still completely valid JSON. So what if there was a way to take this JSON data, which can be in a bunch of different forms, and then flatten it down into one consistent form that's very easy to work with? And luckily for us, a tool to do that does exist, and it's called Gron, and that's what we're going to be looking at today. Now, if you don't know what I mean by flattening the JSON, I guess the best way to describe this would be to actually show you. So over on my terminal here, what we're going to do is I've got this JSON file that I've just called gron.json. And it doesn't really matter what the information is in here. It's basically just the information that GitHub stores for the repo containing Gron. So as you can see, this is just a completely normal JSON file. So we have objects, we have arrays, we have strings, we have booleans, and we have integers in here. I think that's all of the types that JSON supports. I can't remember. Doesn't matter. Anyway, so what we're going to do with this is we're going to run Gron, and we're going to pass the file into this. So gron.json. And as you're going to see, the form of it has completely changed. So you can probably already see why this is way easier to use with Grep. So the main reason is that it's in a very consistent form. So you know that every single JSON document that has been passed through Gron will look something like this. Obviously the data and the variables will be different, but it will be in this form. So the way that this actually works is on the left here, we basically have the path to where it would be located in the JSON file. So this is how you'd actually select it if you had this JSON in, say, a JavaScript program. So let's say we wanted to select something like the followers URL. So what we're doing here is we're saying at JSON index 0, which basically means at the root of the JSON document. We want the committer variable, which in this case is an object, and because it's an object, it has variables of its own. And we want the followers URL variable that is contained within that. And in this case, followers URL is set to this string right here. And that same methodology will work with every single other variable within the document. So before we get to working with Grep, let's just have a look at some of the other methods that we can use to use Gron. So if we just write Gron and we don't pass anything into it, this will go into standard input mode. So as you can see, it's waiting for us to type something in. So let's just do a very basic JSON document. Now, I wouldn't normally use this unless I guess I had something to copy in here. But normally if I need to copy something in, I'll just put it into a document first, just because it'll be a little bit easier to work with. What we're doing right now is we're passing in this very basic JSON document that has one key and one value. So if we run Gron with this now, we'll get two values back. Now, the reason why we get two values back is because it's including the root of the document in the returned values. So in this case, JSON is just the absolute root of the document. So the one value we have in here is located at json.test, which does seem to align with what we were saying before. And the other way this works is we just pass in a URL. So I'm just going to use the URL for the data that we were using earlier. So that'll be located at this URL right here. I'm not going to write this out because, you know, that is bound to have mistakes in it. So because I'm using ZSH, I also need to escape this question mark in here. So if I just run this now, as you can see, this is basically the exact same information that we saw before. Now, it might have had an update since I downloaded the information, but it is downloading the information from the same location. Now, with the URL form, we never actually have to use this one because we can use curl instead. So if we just do curl-s and then pass in the URL, what this is going to do is actually go and download the JSON document. And all we have to do then is pipe this through Gron and we get the exact same result. So basically, when you're using Gron with the URL, it's pretty much just doing this in one step. So I guess it's maybe a little bit quicker, and it does make your command chains a little bit shorter. So that's a good enough reason to just use Gron instead of using curl and Gron. Now, the thing that makes Gron really useful is the ungron option. So ungron will basically do the Gron process, but in reverse. So why is this useful? Well, let's just test this out. So if we do Gron and just pass in that document we were using earlier, as you can see, it just prints out the same thing we have on the screen. So let's just pipe this into gron-u. And this will basically revert it back to the original JSON form. Now you can turn off the colorizing if you don't like the colorizing with the -M option, and that turns it back into monochrome output, but let's just leave the color on for now. So what can we actually do with this? Well, as you can see, we have a bit of a command chain going on here. So what if in between this point right here and this point right here, we did a bit of processing? So let's say we did something like, I don't know, fgrep, and let's select everything that says SHA. Okay, so what is this going to do then? Well, as you can see, it severely limits what we're actually seeing. So let's get rid of the Gron-U option. And basically what this is doing is selecting every single line that contains the string SHA. The reason why this is cool is because what you can do here is you can basically go and modify the documents by using awk and grep, like you would be able to do with something like JQ, which I think is really, really awesome. And speaking of JQ, what we're going to do now is take one of the JQ examples which has been converted over to work with Gron, grep, and sed. Now you could also use something like awk, but these are the tools that we're going to be using today. So the first thing we're going to need to do is look at the information that we're actually going to work with, which will be this information right here, which is basically the last 5 commits made to the Gron repo. And as you can see, prints out the information fine. Now the reason why we're doing 5 this time instead of 1 is just because it gives us a bit of extra information to work with this time. So what we're going to do with this is we're just going to redirect this into a file, just because writing this massive command out every single time is going to be a little bit annoying to deal with, and it's going to make the command way longer than it really needs to be. Okay, so what we're going to do now is basically just redirect this into fgrep. Now fgrep, if you don't know, is basically shorthand for grep-f, and basically that'll let you do a fixed string search. So if we just fgrep on this, and we're going to select JSON 0. So basically what this is going to do is select every single line that contains JSON at index 0. So we run this now, and we get all of the information about the first commit. Okay, so let's extend this line a bit more. So let's pass this into egrep. So egrep is shorthand for grep-E, which is basically grep for an extended regex. And what we're going to try and select is the committer name and the commit message. So what we're going to do is pipe this into egrep, and I'm not going to go too in depth into, I guess, the form of how regex works, but basically what we're going to do is select committer.name or commit. Make sure I spell that correctly, .message. And as you can see, it's selected 2 lines here. So the committer name is GitHub, and the commit message is this pull request right here. Okay, so what's going to happen if we take this line right here, and then we pipe this back into ungron? So what this is going to do is turn this back into a JSON document, but only containing those things that we saw there. So commit, committer name, and you see GitHub right here, and then the message for the actual commit itself. Okay, so we can also do something else interesting here. So let's get rid of this ungron and have a look at this information again. So we have a lot of this extra information here that we might not need. So in this case, all we care about is the name and the message. We don't really care about the rest of the tree in here. So is there a way that we could go and actually remove this? And it turns out that we can, because what we can do is pipe this into sed, and we're going to do sed-r. And what we're going to do is basically do a string replacement. So we're going to replace commit or committer followed by a dot with nothing, and we're going to do a global replacement of that. Okay, so what this is going to do is, as you can see, it's removed commit and committer from both of the lines. So now we're left with JSON at index 0.name and JSON at index 0.message. So can we convert this back into a JSON document then? Well, yes, we can, because this still is completely valid JSON. So if we then go and pipe this into Gron-U, and as you can see, the JSON we have here is considerably smaller now. And because we know the entire document is using the same variables, what we can do is we can actually go and modify every single one of the commits. So if we just run the previous command, but without the fgrep this time, so I'll just move my camera down. So this is the same command minus the fgrep, and also we're going to get rid of the ungron, just so we can see what Gron is actually giving us. So if we just run this now, as you can see, we have JSON at index 0.name, JSON at index 0.message one name, one message, two name, two message. Okay, well, let's see what this is going to do if we go and pass this through ungron now. So pipe this into gron-u, and as you can see, basically we have an array of all of the commit messages and all of the commit names, each contained within their own little objects. Okay, let's go back to working with one commit just so it's a little bit easier to see everything that's going on. So what we're going to do is re-add the fgrep in here. So fgrep on JSON at index 0, and then pipe this into egrep. Okay, so now we're back to working with just one commit. Okay, so let's add a bit more into this egrep. So what we're going to do is we're basically going to select every single one of the HTML URLs that are contained within the parents array. So if we just say or parents.star HTML underscore URL. Now you'll see in just a second why we're doing the dot star. So that's actually parents, not parent. Cool. As you can see, we have an array containing two objects. Each of those objects contain a variable called HTML URL. So let's just run this without the ungron just to see what that's going to do. So as you can see, what we're actually trying to match on is parents with this thing right here, .html URL. So we have to find some way to basically ignore whatever's going on in this section right here. And the way we can do that is by doing dot star. Okay, so let's try this a little bit differently now. So what we're going to do now is we're going to modify our sed statement. And basically what we're going to do is remove the HTML URL and basically make sure the strings are located directly within the parents array. And the way we're going to do that is we're going to modify this sed here. So if we just add another string replacement in here, and what we're going to match on is .html underscore URL. And because we're using a dot, we have to escape the dot. And we're going to replace this basically with nothing. Now, I'll run this first without the ungron, and then I'll show you what it looks like with the ungron. So as you can see, we still have the parents array, but we've now eliminated the HTML URL variable, so these strings are now contained directly within that array. So let's see what that looks like with ungron now. So gron-u. So as you can see, we have three things contained within this JSON document. So we have the message and the name that we had before, but now we also have a parent array that contains two strings within it. So as you can see, this is how powerful Gron can be. You can take an original JSON document and then completely change how it looks just with a few simple commands like this. But if you do need a few more examples, there are a couple located on the GitHub page, so feel free to come have a look at these. And you should get a pretty good understanding of how to actually use Gron, or at least an idea about what you can do with Gron. So one thing I do want to mention is what's mentioned at the bottom down here. So this tool isn't really supposed to replace JQ. JQ is a very, very powerful tool for working with JSON. This is more supposed to show you what the path to something located within a JSON document actually is, and actually does let you work with tools like Grep and sed if you'd prefer to do that instead of working with something like JQ. So I think that's pretty much everything I wanted to say about Gron. So I think this is a really, really awesome tool, and if you're the sort of person who needs to work with JSON, but you'd much rather prefer working with the tools you already know, like Grep, Awk, and sed, so on and so forth, this is probably a good idea to include in your toolchain. Now, I know you can work directly with Awk and sed with a JSON file. It's just a massive pain to do, and this makes it significantly easier. So I think that's pretty much everything I want to talk about today. But before I go, I want to thank my patrons. So a special thank you to Joachim, Craig, Nathan, Andrew, Montezar, P.D. Road, Tony Donald, and Zilva. If you want to join the Patreon, there'll be a link to that down below, as well as my Amazon affiliate links where you can buy the gear I use in this channel, or anything else you want, and I'll get a small kickback for it. Also, remember to go check out my podcast. That is Tech Over Tea, available on Library and YouTube, and the audio version available wherever you listen to audio podcasts. Also, remember to check out this channel available on Library, BitTube, and BitChute. And remember to smash the like button and leave me a comment down below. And remember to subscribe and ding the little bell icon down below as well. So I think that's pretty much everything for me. I don't know how much you guys picked it up, but my nose is blocked right now, and I've had to like sneeze between different cuts. So hopefully the video is still good. It was fine towards the start, and then like towards the end of it, it got to be a problem. So hopefully it's not too bad. I don't know. We'll see what happens in post and when it actually goes up on YouTube. So I think that's pretty much everything for me, and I'm out.